CCDs. The CCD in your camera is about the size of one of your small fingernails. The CCD chips on Kepler are a couple of inches square in pairs, and there's 42 of those. In your camera, you might have a few megapixels. If you have a really nice camera, you might have 10 megapixels.
We have 96 million pixels, and they have very low noise, so we can find very small planets.
Once Kepler is launched from the Earth, it will go into what's called an Earth trailing orbit. Astronomers call that a heliocentric orbit, which means sun-centered orbit.
It looks at the stars continuously, day and night, 365 days a year, and it slowly moves away from the Earth, orbiting the Sun by itself.
And from there, it will point itself at the Kepler field and stare at the Kepler field nearly without blinking for 3.5 years at least, maybe longer if we have an extended mission.
Kepler will be looking in a region of the sky that you'll see almost every night in the summertime.
The field of view is kind of nestled underneath the wing of Cygnus the Swan, between Cygnus and Lyra. Now, in that area of sky, there are something like 6.5 million stars. Why do we need so many?
Because of the way Kepler looks for planets, we have to have planetary systems that are lined up so that the planet actually passes between the star and Kepler telescope in its orbit.
The probability of that happening if you just throw stars randomly down in our galaxy is something like 1 to 10%. It's small. So of those 6.5 million scattered over that 100 square degrees, only maybe 200,000 are interesting to us.
We select the 170,000 or so that are most suitable to look at for planets with the Kepler telescope. Finally, we expect to end up with somewhere between a few hundred and a few thousand signals that are really planets around the stars that we're looking at.
Well, this is the first time that photometry, the measurement of the brightness of stars, will ever be done at this level of precision. And it will be done simultaneously on more than 100,000 stars continuously over a period of years.
We're somewhat like pioneers, very much like the explorers that were looking for new lands to settle. And that's how I see what we're doing. We're looking in this region of our galaxy for other habitable worlds.
I think people everywhere want to know whether with all the stars out there, do they have planets that are Earth-sized? Are Earth frequent or are they rare? And this gives us that answer. It's the next step in mankind's exploration of the galaxy.
There's two extreme answers that Kepler might give us. It might tell us that there's an Earth-like planet practically around every star we look at. Imagine the possibilities for life in the galaxy or life in the universe.
If, on the other hand, we found out that Earth was very special and that the typical star, like the Sun, is not hosting planets like the Earth, I think that would be a real surprise as well and would really make us reconsider the special nature of Earth.
We are now finally at the point where our technology allows us to build a machine that can make the observations to scientifically answer this question.
How many stars like the Sun did develop planets around them like the Earth? I think that's such an important question to everyone and so interesting that we really have to do it, and it's a once-in-a-lifetime opportunity right now.